previously, we talked about finding the surface area, lateral area, and volume of our prisms and our cylinders. And we said those were similar because they had two congruent faces that were parallel to one another with some section in the middle. Today, we're going to be talking about our pyramids and cones, also built very similar. They're going to have one singular base, and they come to some point, right? Okay, so first, let's just label the pieces that make up our pyramids. So you could have a pyramid that's slanted like this, like oblique, right? Like our oblique cylinders or prisms. Or you can have what they call just a regular pyramid, where it's going to have that height that's perpendicular to the base, forming that 90-degree angle. Okay, so here, this point at the top is our vertex. And this side here is from our lateral faces. So the lateral faces are what these two arrows are pointing at. This is an edge of that lateral face, so this would be called a lateral edge. While the piece on the bottom is what we call the base, which is what this arrow is pointing at, which would make this piece here a base edge. And then over here in our regular pyramid, they're pointing at two different lines. Like we said, because this line was perpendicular to the base, we should know that this one is what we would consider to be the height of the pyramid. While this line is perpendicular to this base edge. However, it's a slanted line, right? So it's not the actual height. It is the height of that triangle, right? This is what we would call the slant height. And we are going to use slant height in our formulas here in a little bit. Slant height is always going to be denoted with a script L. So we'll use H for height and then the script L for slant height. Okay, so we've got our pieces here. Now let's talk about what our formulas are for lateral area and surface area for our pyramids. So for lateral area in a pyramid, our formula is 1/2 P times L, where P stands for the perimeter of the what? The base, right? And then the slant height, as we know, is going to be the height of one of those triangles' bases. And remember, lateral height is everything except the base, right? So my formula for surface area is going to be the same thing, but include the base's area, right? So it would be the base area plus that 1/2 perimeter times slant height. All right, so now let's look at our cones. So our lateral surface is that curved part, right, besides the base. We should know that this bottom circle is the base of the cone. Okay, this line right here that's perpendicular to the base, coming right down the middle, is what we would say is our height. Right, it goes from the vertex to the base. That point up here is our vertex. And then this measurement right here, just like in our pyramid, is what we would refer to as the slant height. Which again is denoted with a script L. All right, so just like our cylinders and prisms, we're going to have similar formulas because they are created similarly. Same is true about our pyramids and cones. The difference is in a cone, we know our base is always going to be a circle, right? So if the formula was 1/2 P times L, P stands for perimeter. What do we call perimeter in a circle? Circumference. And what's our formula for circumference? So 1/2 2 pi r. Well, the 1/2 and the 2 just kind of cancel each other out, right? So it'll just be pi r for the perimeter times the slant height. And our surface area is the same thing, but add the area of the base. And how do you find the area of a circle? R squared. So our surface area will be pi r squared for the base plus our pi r slant height. So again, our slant height is denoted by L. If they don't give you L, you might have to solve for it, right? So the ways we could do that would be to use trig, or if they give us two sides, we could use Pythagorean theorem, right? So now we know our formulas. We have a plan for if they don't give us L, how we can find it. So let's look at this first example here. So for this first example, we are going to find the lateral area of each face. So find the lateral area of each face. Alright, so to find lateral area, our formula was 1/2 perimeter times slant height. Okay, so we have enough information here where we could find the perimeter of our base, but they did not give us this line over here that we call the slant height. They did give us this line here, which is the actual height, and then this piece down here on the bottom, how long should that piece be? 8, right, because it should be, because our base is a square, it should be half, because it goes halfway in to our pyramid. So this should have a length of 8. All right, so if I know that this piece is 15 and this piece is 8, what could we do to find our slant height L over here? Pythagorean theorem, good. All right, so we're going to have our 8 squared plus 15 squared equals slant height squared. What should our slant height be? 17, right? Because we're going to get 289 here, and we take our square roots. So our slant height is 17. All right. Now, they did just ask for the area of each face, not the total lateral area. So really, I don't need to find the area of the all of the lateral faces. I just need to find the area of one. And what kind of shape are my lateral faces? Triangles, right? So I need to find the area of one triangle. So area of each lateral face is what we are looking for. And like you guys said, those are triangles. And what's our formula for area of a triangle? Very good. 1/2 times the base. What's the length of the base here? 16. Times the height of the triangle, which is really this line here that we referred to as the slant height, right? And what is the length of the slant height? Right. So we got 1/2 times 16 times 17. So what would the area of one of our lateral faces be? 136. And if they had wanted the entire lateral area, instead of using 16, we would have used our perimeter of the whole base, right? Okay, example 2. For this one, we are going to find the surface area. All right, so this time we've got a cone. What did we say our formula was for surface area of a cone? All right, we have something for R, but do we know the slant height? How could we find the slant height? Pythagorean theorem again, right? So I know this piece is 6, I know this piece is 5, I'm looking for that outside edge there. So I'm going to have 5 squared plus 6 squared equals my slant height squared. What is 5 squared plus 6 squared? So we have 61 equals L squared. And to get L, we would take the square root, right? If they had asked us to keep our answer exact, we would keep L as square root of 61 since there is no perfect square root, but they didn't say it has to be exact. So we can estimate approximately what the square root of 61 is. What would we say that is? Yeah, that works. So the slant height is 7.81. All right. Now I'm just going to plug that into our formula here. So we've got pi r squared plus pi times r times that slant height. Again, if we were trying to keep it exact, we wouldn't multiply by the pi. We would try and keep it as exact as possible. But since they did not ask for the exact answer, we can just go ahead and multiply and add all these things. What should we get for our surface area? 64.0405. Pi, yes. And if we multiply by pi? 201.2. Very good. So we get 201.2-ish. All right. So if they don't give you the slant height, it's up to you to find it. Sometimes they give you 2 pieces, like they did here. But remember, if they don't give you 2 pieces, you can always use trig to find it. All right?